Morning, my fabulous chemistry minions. Take number 4 or 5 on this guy. It is going to end up being a pretty long video because we have two major things we have to learn. We have to recite the names and locations of the 3 subatomic particles. By all means, who are they? And we have to figure out how many of each. So there's going to be some redundancy in this because this is some really important stuff. I'm going to try and go quick. I cut the last video at 13 minutes, and there was still more to go. Protons, pointing towards letter A. Protons are that positive little thing on the inside. They're the nucleus. Has a mass of 1 and a charge of a positive charge. So has charge, has mass. I will call protons king. They are the most important thing. Okay? They have a plus charge. Neutrons, B. Letter B is pointing towards those little white spheres. They're also in the nucleus. They have a mass of 1, but no charge. So they are different than a proton. They have mass, but no charge. Letter C is pointing to the nucleus, which is the center space. This is the dense core of the atom. It has an overall positive charge because it has protons in it. Protons and nuclear charge will be synonymous. Some of us will struggle with that. Orbitals. Letter D is pointing towards the orbitals. This is where electrons are located or reside. You can write located, and I'll take that. Okay, especially if you're listening. Now, electrons, this is where life gets complicated. You can say they have no mass, and I'm okay with that. That number is just a matter-of-fact thing because you're taking Regents chemistry. You should know what things really are. That mass is really 1 divided by 1,836. Go ahead, put that in your calculator, press equals, and you'll see it as a super, super, super small number, basically 0. So for our purposes, electrons have no mass and a negative charge, and that's where things will get very complicated. Okay. Valence electrons. These are the electrons in that outermost shell. So if you go back to that picture, the outside ring farthest away from the nucleus, however many electrons are there, that's going to tell me a lot about its reactivity. So this next statement, they are responsible for how the atom reacts or behaves chemically. That one statement sums up the next 7 or 8 units that we take care of. So we are going to deal with electron chemistry heavily. They are responsible for how the atom reacts or behaves chemically. Please do not fight that statement. Please internalize that statement, know it, love it. It will help you with everything we do. There are other electrons in an atom. The inner shell electrons are called kernel electrons, and they're just more of a matter-of-fact thing. We need them when we talk about how many total, but they don't really do much as far as reactivity or how things go. So let's sum up what we just learned real quick. Protons have a positive 1 charge, and they have a mass of 1. We can eventually leave this AMU out. As long as they have it's 1, we're good. They are located in the nucleus. There's 2 notations. I can use just a P for protons, or I can put in the actual nuclear symbol piece where the top number is the mass and the bottom number is the charge or the nuclear charge or the atomic number. Remember, those 2 things are synonymous. So when I'm looking up at my tile just to make sure I read it right, and that's where I get that information. So how do I figure out the number of protons in any atom? Well, simply look at the atomic number, and we'll find on the next slide where exactly that atomic number is that we need to look. Okay. Neutrons have a charge of 0, but they do have that same mass. So they have something similar to protons. They have a mass of 1, and they're located in the nucleus, but they're lacking that charge. So they're not quite the same thing. They are different. Okay. Neutrons have a symbol of little n, or again, I can put in the mass up top and the charge on the bottom, and the charge for a neutron is 0. That is how the notation is, by the way, on your reference table, the bottom one with the 1 and the 0. I'm going to take the mass number, or the atomic mass, and subtract the atomic number from it, which is the number of protons. I do that because protons plus neutrons equals the mass. Rearrange that thing around, and I get up with neutrons equals mass minus atomic number. Okay, electrons have a charge of -1. That's where our life gets difficult, I promise. And you can write 0 here. It has a relative negligible mass, so that is really 0. It has no mass. Okay, it is located in the orbitals, or you could say outside the nucleus, but the correct word is orbitals. They have an E with a minus symbol. Now, this is from last year, and I just need to let you know, this is no longer acceptable. This was the first year on the Regents exam this past year where New York State said the little e actually had to have the negative. I don't know that I agree with that. Capital E is energy. So little e to me has always been electrons, whether it has the negative or not. But this year, you got dinged on the test this past year if you didn't put the negative. So we're just going to go with E with a little negative to make sure nobody gets dinged. Now, this is a loaded statement. In a neutral atom, the number of protons and the number of electrons are equal. I have the same number of positives as I have negatives. Put them together, it cancels out to zero. That is by definition what a neutral atom is. There is more to it, of course. This is the actual equation. We're going to say charge equals protons minus electrons. In a neutral atom, the charge is zero. So if I have zero equals protons minus electrons, I can infer that protons equals the number of electrons. We need to know that the charge is zero for atoms. And notice I left the word neutral out of there. Atoms is a loaded word. Atoms means there is a neutral overall charge. If it's an atom, it has the same number of protons and electrons. If the number of electrons changes, because we're going to find the number of protons can't, if the number of electrons changes, it's no longer an atom anymore. It's something else, and we'll use that word specifically. Okay. Nucleons is just a catch-all word for anything residing in the nucleus, hence protons and neutrons. Not that big a deal, but we need to know what that means. And then neutral atoms, again, net charge of zero. Therefore, the number of protons equals the number of electrons. So for today, finding out protons and electrons, for the first set, it's going to be equal. And then we'll get into ions in the next video, and life will change. Okay. Looking at my tile on the periodic table, the average atomic mass, or the atomic mass up top, is the average of all the relative abundant isotopes. We're going to get into that. That's a whole different video, how we calculate that. For right now, we're just going to use this as a whole number, round that down to 12. Okay. That's how we use it to calculate neutrons. So the atomic number is the number of protons in every element. Carbon has 6 protons, period. If it has a mass of 12, I'll do 12 minus 6, it has 6 neutrons. If it's carbon 14, it's 14 minus 6, and I have 8 neutrons. We will figure that stuff out. Electron configuration, this is the number of electrons in each energy level. We add up each of these numbers to get to the total number of electrons. The 2 plus 4 is 6. I need 6 pluses and 6 minuses to cancel out. This is not 2 minus 4. This is 2 dash 4. And what that means is there's 2 electrons in the first energy level and 4 electrons in the second energy level. We will work on how we populate those and learn lots and lots more about that stuff. C is the symbol for carbon. This is the letter used to identify the element. You see all of them there. We've gotten to know a few of them. You need to know that the first letter will always be capitalized. If there is a second letter, it will be lowercase. In the upper right-hand corner, these are the oxidation numbers. These are just possible charges, and a lot of kids want to go right to them to figure things out. This is possible charges of an ion that could be made from the element. So we don't always attach those numbers on. Those are just a list of reference numbers of ones that are acceptable when we are calculating those things. We deal with carbon, it is carbon atom first, unless we know otherwise. So these are going to take a back seat, these oxidation numbers, so trust me on that. Little quick review, average atomic mass. This is the average mass of all the naturally occurring isotopes. There's a whole video on that statement. Okay, a little bit of math. The atomic number, this is the number of protons in every atom of that element. Protons is the big thing. Atomic number equals the number of protons. It does not say that anywhere on the reference table. That's the piece you need to know. Electron configuration. This is the number of electrons in each energy level. We add up all the numbers to get to the total number of electrons. It should equal protons. These are just the possible charges of an ion that it could make. So carbon can make a -4, a +2, and a +4. That doesn't mean that it is there yet. Those are just possibilities, so that once we've calculated said ion, then we can see if it matches and we're good. Okay. Symbol, of course, always capital letter first, followed by lowercase. Hardest one is chlorine, Cl, because the L is the same font as the capital I in iodine. So we need to keep track that Cl is not Ci. Okay. How do we write these things down? 3 simple element notations. This is the most common nuclear symbol because it gives me the most information. It gives me the symbol, and it gives me the mass and the atomic number. So this is going to come into play when we do isotopes. We got the symbol, tells me it's carbon. Carbon will always have 6 protons, but it has a mass of 12. There's easier ways to write that. I could write carbon 12, which is writing out the name and its mass, or I do this, just C12, where you're going to see a lot of just the symbol and the mass. And there is such thing as a C14, and I can go backwards from C14. And this condensed formula is something you're gonna see on your practice pages, and the nuclear symbol is something you're going to see on the practice pages because you're going to need to be able to do both. Okay. How do we find out the atomic number of an element? Well, look at the bolded number in the bottom left-hand corner. It does say atomic number. So I'm going to look up. It does say atomic number is the bolded number. So that's good. If I'm asking for the atomic number, I just looked that up. It's in the lower left-hand corner. What it doesn't say is that is also the number of protons. So if I'm going to look for the protons, it's still just the bolded number in the bottom left-hand corner of the elements tile. Okay. The atomic mass it's not bolded, so it shouldn't say that, but it is in the top left corner of the elements tile. So we can get rid of bolded. Just locate the number. Cross that right out. Okay, locate the number in the top left-hand corner of the elements tile. How do we find the number of neutrons? Well, neutrons equals the atomic mass minus the atomic number. I can rewrite a different statement here, and I could say that the mass is going to equal protons plus neutrons. Well, if I want to solve for neutrons, I'd have to subtract protons from the other side and get neutrons equals mass minus protons, which is the same thing that I have here because protons and atomic number are the same thing. We got to make sure we can go backwards and forwards with that and not get caught up. Okay. How do we find the number of electrons? Well, you look up the electron configuration and add up all the numbers. For the first set of practice, the number of protons and electrons will be equal because I will be dealing with just neutral elements. We haven't gotten into ions yet. Next video, we make things more complicated. Okay. Nuclear charge, another code word for number of protons. So it's just the bolded number in the bottom left-hand corner, which is the atomic number. The number of protons equals the nuclear charge. That is going to be a statement that we need to make sure we can fill in and understand. Okay, because we're going to need to be able to fill in those pieces. How do you find the nuclear symbol? These are just the letters that represent the atom. Remember, first letter is always capitalized, second letter is lowercase. Okay. And the atomic mass is in the upper left-hand corner, and I put the atomic number in the bottom left-hand corner. So for the nuclear symbol, I need those 3 things. You're going to be asked to do a nuclear symbol, so make sure you can find all 3 of those pieces. And with that, we are donezo. Sorry, I know it's a lot, but this is the basis of the whole unit. I want to make sure we got it. Okay? 2.